Here we will see the actual chemical reaction taking place. The copper sulfate is poured into a beaker and you can see the clear blue solution. When ammonia is added, dropwise, you can just about see some pale blue precipitate and some dark blue solution. The pale blue precipitate is a copper hydroxide precipitate that is being formed. As we stir it, you can see it all looks pale blue. If an excess ammonia is added and we stir it up, you can see the deep blue complex. This is the result of a ligand substitution reaction. If we now add some hydrochloric acid, you can see a new colour change. The blue will become a green colour. Copper chloride, the new complex that is formed, is actually yellow, but an equilibrium is set up so a clear green solution is observed. So here is our copper-water complex. You can see 6 coordinate bonds, each with a water ligand. The central transition metal ion is a copper 2+ ion. The ammonia has now been added and will quickly substitute some of the water ligands. When hydrogen chloride gas is added, the first thing that happens is the formation of the hydroxonium ion. This leaves plenty of chloride ligands. The chloride ligands can then substitute for the ammonia ligands. You notice the shape has now changed from an octahedral complex to a tetrahedral complex. The bond angles were 90 degrees, they are now 109.5 degrees.
The first observation was from a blue solution to a pale blue precipitate. The pale blue precipitate is formed by this reaction. The next observation was from a pale blue precipitate to a deep blue solution. The first ligand substitution occurs when 4 ammonia ligands substitute 4 water ligands in this reaction. Another ligand substitution occurs when concentrated hydrochloric acid is added. It forms a new tetrahedral complex, which is yellow, but because it's in equilibrium, it appears green.